Hello and welcome to Data Analysis with Python, Zero to Pandas. This is a free certification course being organized in collaboration by Jovian.ml and Free Code Camp. My name is Akash and I'm your instructor for the course. I'm also the CEO of Jovian.ml and you can find me on Twitter at @Akash. And Jovian.ml is a sharing and collaboration platform for data science. We've been sharing all the course materials with you using Jovian.ml and you've been submitting the assignments using Jovian as well. And freecodecamp.org is a place where you can learn to code for free by building great projects and interacting with a worldwide community. So do check it out. Now the course Zero to Pandas is a coding first introduction to data analysis with Python, and we've had video lectures every week with live coding on cloud-based Jupyter notebooks. We've also had assignments for you to practice the concepts and a course project that you're probably currently working on. And once you do these, you will be able to earn a certificate of accomplishment, all free of cost. And this will be a verified certificate that you will be able to showcase on your LinkedIn profile and on your resume. And finally, so the topic for today, our final lecture is Exploratory Data Analysis, a case study, where we will be taking everything that we have learned in the entire course and bringing it together into a single project where we will be analyzing a real world data set, and we will be asking and answering some interesting questions about the data, and we will figure out how to use the right tools and techniques and libraries and functions at the right places, and we will be drawing some inferences and conclusions. So this is in some sense a walkthrough of a real world project that you might do in data analysis. So with that, let's get started. So the first thing you should do is go to the course page zerotopandas.com, and on the course page you will be able to find all the course materials. So today, since we are looking at lesson 5, so you can lesson 6, so you can scroll down to lesson 6, Exploratory Data Analysis, a case study, and click open. This will take you to the course page, the lecture page, where you will be able to see the video. So the video that you're watching right now will be available as a recording for you to review. Now for each lecture, we have been using Jupyter notebooks. So today we will be using the Jupyter notebook EDA on Stack Overflow Developer Survey. So you can just click on this link and that will bring you to this Jupyter notebook. Now you can view this Jupyter notebook, you can read through it. But what we would want to do is we would want to run this notebook. Now you need not run it right now if you're watching live. You just watch the lecture, and after the lecture you can run this notebook and experiment with it. But I'm going to run it right now and we are going to work through it. And we click the run button and click run on Binder to start the notebook up on the Binder platform. Now this might take a couple of minutes. And in the meantime, I just want to show you how to ask questions. So if you have questions during or after the lecture, you can come to the lesson page and here click on the discussion forum link. And this will take you to a page on the discussion forum. This is where we've been having all our discussions, and you can use this thread for asking questions. So all you need to do is click the reply button and post your question. There's a big blue reply button and you just post your question and hit reply. And either somebody from the course team or somebody from the community will answer your questions. Okay, so please ask your questions on the forum and also answer questions if you already know answers to some of the questions that have been asked here. So returning to the notebook, this notebook is called Exploratory Data Analysis using Python, a case study. And we have clicked the run button and selected run on Binder. So finally here we have our Jupyter interface running. So let's just open up the notebook here, Python EDA Stack Overflow Survey.ipynb. And the first thing that I'm going to do is I'm going to click kernel, restart and clear output. This is to clear all the outputs so that only the code remains and we can run the code and see the outputs for ourselves. Then I'm also going to hide the header and the toolbar. You need not do this, but I'm just doing this so that we have a little more space to work with. So in this notebook, Exploratory Data Analysis using Python, a case study, we will be analyzing responses from the Stack Overflow Annual Developer Survey, and we will apply all the things that we have learned so far about Python, Jupyter, Numpy, Pandas, Matplotlib, Seaborn together, and we'll bring everything together. Now you can run this code online just in the way that we have by using the run button that we just used to run this code on Binder, but you can also run this code on your computer locally. So you can follow the instructions given here under option 2. Now, as I mentioned, we'll be analyzing the Stack Overflow Developer Survey dataset for our analysis. And this is an annual survey conducted by Stack Overflow. and you can find the raw data and results on this page, insights.stackoverflow.com. In fact, we will be analyzing the results from 2020, but you can also see the survey from the past years. So the first thing that we would want to do is to download this dataset into Jupyter. And there are many ways to do this. We've seen many ways over time across different lectures. So the first thing that you could do is just download the CSV manually and upload it using Jupyter's graphical interface. So let's do that. Let's see how to do that. So you click download full dataset, and that points us to a Google Drive link. And then you can download the Google Drive link. And so here I'm downloading it to my desktop. And then you can unzip the Google Drive link. So once you unzip this link, you will see this folder, Developer Survey 2020. And if you open up this folder, you will see here that you have a PDF and then a bunch of CSV files and then a README file. So you can go through the README to learn more about the dataset. But probably the interesting files for us are going to be the CSV files. So we might need to upload these CSV files onto Jupyter. So the way to do that is to come back to the notebook, go File, Open, and then you will find an upload button here. So click upload and just select the file that you want to upload. So in this case, let's say as an example, let's try and upload survey results schema.csv. So one by one, you can upload each CSV file that you need. Okay. So that's one way to do it. You can click the upload button to complete the upload, but I won't do that right now. Then there's another way to do it. If you have a direct link to the raw CSV file. Okay, so this is very important. If you have a link which points directly to the CSV file, so a Google Drive link or some other link will not do. It has to point to the raw file. Then you can use the URL retrieve function from the URL lib.request module. So this is what we've used in our previous lectures. We've used this in the lecture on Numpy and Pandas. So you can review those lectures 3 and 4 to see how to use this, or just check the documentation. But today we are going to use a third method. We are going to use a helper library called Open Datasets. So this is a library that we have created for you to make it easier for you to do data analysis, where we are creating a curated collection of datasets for data analysis and machine learning. And these datasets can be downloaded into Jupyter with a single Python command. So this is how it works. We have to install this library, pip install open datasets. So let's just come back to the Jupyter notebook and let us run pip install open datasets. So this is installed the open datasets library. Then we import open datasets as OD. So we just import open datasets as OD. And then all we need to do is run od.download and then pass in a dataset ID. So we have currently added about 6 datasets here, but we will be adding many more. We're trying to make sure that we have at least 100 datasets here by the end of this week. So you will see more here. And we simply need to pick up the ID of the dataset that we want to use. So here we have the Stack Overflow developer survey, and we need to paste that ID here. So we just do od.download, and under the hood, this is going to fetch the list of files in the dataset, and it is going to download all the files. So you can see that these URLs have been fetched and they have been downloaded into this folder, Stack Overflow Developer Survey 2020. Okay. So with that, we seem to have the dataset downloaded. Once again, you can go File, Open, and you can check that there is a folder here, Stack Overflow Developer Survey 2020. And this contains the README and then the public file and the schema file. Okay. So those are different ways to download the dataset. The important point is to have the files next to your Jupyter notebook, irrespective of how you get them. All right. So let's just check, import the OS module and verify once again that the dataset is actually downloaded. So when we run os.list_dir on the Stack Overflow Developer Survey folder, we see a README, we see some survey results, and we see the survey results public, and we see a survey results schema. So there are 3 files, and you can go through these 3 files. So the README contains some information about the dataset, and then the survey results schema contains a list of questions. And so let's maybe just load up that file and view that file as well. And then there are the survey results public. So this contains the full list of responses to those questions. Okay. So we will load the CSV files using Pandas, and let's import Pandas as PD, and let's use the pd.read CSV function, where we will pass in the path to the survey results public.csv file, which contains the survey responses. and we are going to call it survey raw df. So the reason for calling it that is because this is going to be the raw data set, the unprocessed data set that we are loading up. And then we are going to do some modifications to create a prepared data set for analysis. So here we create a survey raw df by calling pd.readcsv, and let's take a look at this. So this is what the data frame looks like. It looks like it has a whole bunch of columns. In fact, in total, there are about 61 columns. So 60 of them are each column corresponds to one question from the survey. And here what is not the full question, but just a short form. And then there is also one column which contains a respondent ID. So these survey results are anonymized. So there is no personally identifiable information like first name, last name, phone number, email, etc. So results have been anonymized, and every respondent has been given an ID, which is not really useful for us. There's one column if you want to use the respondent ID, and then there are 60 columns, one for each question. Now, if you want to know what the actual question was, this is where you can use the other file, which is survey results schema.csv, and we'll see that in just a moment. But you can see at the bottom here that there are over 64,000 responses, and as we said, 61 columns. And let's just see a list of columns in the data frame. So we can use survey raw df.columns to see a full list of columns from the data frame. A lot of these may not make sense, so this is where we need to use the schema file to understand what these columns represent. So here we have this file. Let me just put it on a separate line. So here we have this file schema, survey results schema.csv. And maybe let's load up the entire file first. So we can just do pd.readcsv and schema file name. So this file is a CSV file that contains two columns. One of the columns, the first column, is titled column. So this corresponds to the names of all these columns except respondent. So main, branch, hobbyist, etc., etc. Actually, it contains the respondent ID as well. So for each of these columns, you can see the actual question here. So for instance, main branch means this question was which of the following options best describes you, etc., etc. Hobbyist means do you code as a hobby? So that's what the correspondence is. Now it's okay to have it in this format, but the schema data frame is primarily going to be used to access the question for each column. So what we might first want to do is we might just want to set the index while loading the file, and set the index call argument to this column, so that when we read it, now we just have one proper column, and then the column itself is just the index. So now we have the respondent, and then we have this one column question text. So now we can access the question text using the respondent as a key, right? So you can, for example, imagine doing .loc and then passing in the respondent key here to access the question text for the respondent. Okay. So now let's simplify it a little bit further. Since we only have one column, we don't really need a data frame. Data frames are required when we want to go over multiple columns of data. So we can simply get the question text out of this, and that will give us a series. Okay, looks like this is stuck. Yeah, so we can just read the CSV file, the data frame, and from it just get the question text column out of it. So that will give us a series, and that is all we need really. The series has an index, which is the column name in the main data frame, and then the series has a value. Each value corresponds to the full text of the question. Okay, so that is what we have done here. We've created a schema raw, which is where we read in the schema file with the index column as column, and we just create a series question text. So here is a schema raw, and we can now use schema raw to retrieve the full question text for any column in survey raw df. So now we can check, for example, the years code pro column. So you can see here that years code pro column in the survey data frame corresponds to the question, not including education. How many years have you coded professionally as a part of your work? All right. So with that, we have loaded up our data set, and we have converted them into data frames. We have it in a way that we can now work with it using the tools that we know and understand. So we are now ready to move on to the next step of pre-processing and cleaning the data for our analysis. And before we do that, it's always a good idea to keep saving your work from time to time, because we're running this on an online service binder. So we simply select a project name. So here I'm selecting a project name Python EDA Stack Overflow Survey. We install the Jovian library, and then we import Jovian and run jovian.commit. And this is going to ask us, the first time this is going to ask us for an API key, which we can get from our profile, and just paste it in here. And that is going to then commit this notebook to our profile. Yeah, so now this notebook has been committed. So you can view this notebook on your Jovian profile whenever you want to. Wherever you commit from, whether you commit from Binder or you commit from your local computer, everything gets saved on your Jovian profile. And then you can take this and run it on Binder whenever you need it to continue your work. All right, so moving ahead, now we have our data as data frames. And while this survey contains a wealth of information, it contains about 65,000 responses to 60 questions, we will limit our analysis to a few areas. And this is what you might want to do for your projects as well. Just pick a theme for your project and do not try to do a lot of different things with the dataset. So we will limit our analysis to 3 areas. The first would be understanding the demographics of the survey respondents, who it is that has taken the survey, and the global programming community in general, and understand if the survey responses are representative of the global community. We will also try and understand the distribution of different programming skills, experiences, and preferences. So specifically like things like programming languages, which programming languages do people like, which one do they not? And we will also understand some employment related information, professional and information, preferences, and opinions. So something related to the kind of roles people are holding in data science and programming fields. Okay. So to do that, let us select a subset of the columns. So here are some columns for demographics, and then here are some columns for the programming experience, and then here are some columns for the employment. So you know that you can use the schema that we had created to check the questions. So do check out the full questions for each of these before moving forward. And let us just check how many columns we have selected. So we have selected about 20 columns. Okay. Now, what we will do is we'll take our survey raw data frame, and then if we simply pass in a list of columns to it as an index, that is simply going to select a subset of columns. And then we are going to take that data and just create a copy of it and call that survey data frame. So we are creating a copy so that we can modify this without affecting the original data frame, so that if we make a mistake, we can always recreate this from the original data frame. So we create the survey data frame, and we've just taken the selected columns and created a copy. And then we have created, here we are now going to just pick out the same selected columns out of the schema as well, so that our schema also contains just the columns that we need. So we can look at it right now. So here we have the survey data frame. This now has only 20 columns, the columns that we have selected. It still has all the rows. And then we can check the schema as well. So here we see the schema. So you can see here that the schema has each questions for each of the 20 columns. So you can see in total it has if you check the shape, you will see that it has 20 entries. And the survey data frame has about 64,000 rows and 20 columns. Now we can use the info method of survey data frame to see the list of columns and different data types. So these are all the different columns that we had just selected. And you can see that out of the 64,000 plus entries, not all of the entries are non-empty. So for each of the columns, you see some null values, some values that are empty in the CSV file. So Pandas replaces empty values in the CSV file with np.nan, which is a token. It uses for empty values. And because there are so many empty values, and because a lot of rows contain many different types of data, the data type that you see here is detected as object for most of the rows. Now the object data type is okay while we are working with strings. It's not really a problem, but when we are working with numbers and we want to perform some numeric computations and draw some graphs which involve some kind of number processing, then we might need to convert some of these rows, some of these columns into numeric data types. Okay. So far we have just the age and the work week hours as the numeric data types. If you see age here, it has a data type float 64, and then the work week hours has a data type float 64. But there are a few more columns which can also have a numeric data type. So we have the age first code, we have the years code pro, and we have the years code column. All three of these are also numeric, but for some reason they have gotten classified as object. So let's investigate that a little bit. Now, if we just look at surveydf.age first code, and let us look at the unique values for this. So it turns out that most of the values are numbers, and the question, if you're wondering what the question is, let's just check schema.age first code. So the question is, at what age did you write your first line of code or program? And the answers to that are mostly numbers, but there is also an option younger than 5 years and older than 85, which are strings. And we might want to just somehow convert these into numbers or ignore them, because that will keeping them as strings will prevent our analysis. So what you can do, what we will choose to do here is we will choose to replace these with empty values. Okay, and we will choose to convert the rest of these into strings. And the way to do that is to use the pd.toNumeric function. So the pd.toNumeric function, and you can check the documentation, it takes a series or a column and it converts that series into a numeric data, right? So it's going to take all of these and convert these into floats, and wherever it encounters a string, it will throw an error. But what we want to do is we want to ignore the errors and simply replace any non-numeric values with the nan value or the empty placeholder value. So that's why we are passing in errors equals scores. Okay, so this is one thing that we're doing for the age first code. Similarly, we have years code and years code pro. So let's just take a quick look at years code, and years code pro is going to be similar. So years code is including any education, how many years have you been coding in total. And if we take that and we check the unique values of that, so once again, here we have these options like less than 1 year and more than 50 years. Once again, what we are going to do is we are going to ignore those values. We are going to convert these into empty values, and the rest we are going to convert into numbers. So once again, we use pd.toNumeric, and we assign the result back to surveydf years code. So this way we are replacing the columns with a new version of the same column where all the elements are numbers or empty. And then similarly, we have this for the years code pro column. Okay, so go through the other columns and see if there are any other columns that are numeric. But for the time being, we will convert these three into numeric columns. Now, we had two columns earlier, age and work week hours. And then we have three more columns. So in total, we have 5 numeric columns, and we can start seeing some basic statistics about the numeric columns using the describe function. So here we have called surveydf.describe, and you can see that for age, the average age is about 30 of the survey respondents, but the average age of first coding, so the age at which they wrote their first line of code, is around 15. The years of coding is about 12 on average, and so on. Work weeks are around 40. But you will start to notice some problems here. It seems like that the minimum age mentioned is 1, which seems quite unlikely that a 1-year-old infant has filled out this survey. And the maximum age appears to be 279, which once again is quite unlikely. And this is a common issue with real world data in general and with surveys in particular. You have to understand that surveys are filled by people, and there is no obligation to enter the right information. So sometimes people may intentionally putting the wrong information, while other times there might be accidental errors while filling in. Like maybe somebody was looking to type 17, but they did not press the 7, and so it ended up being 1. Or maybe somebody was trying to type 27 and they accidentally pressed 9 as well, and that ended up with 279. So we should try and solve for these. For each column, you should go through it and try to figure out if the values in the column make sense. And a simple fix in this case would be to simply delete the rows where the value in the age column is higher than 100 years or lower than 10 years. So we are basically saying that those entire responses are invalid. Maybe they're invalid unintentionally, or maybe that was intentional. And to delete the rows, we can use the drop method of the data frame. So we just call surveydf.drop, and then you can just go try and understand the syntax here. What's happening is that we are first checking the list of values surveydf.age where the age is less than 10. So that's going to give us a Boolean series of true and false for each row on whether the age is less than 10 or not. We then use that to select the rows. We then use that to select only those rows where the age is less than 10. And then to drop to a surveydf.drop, we need to pass an index. So if you just call .index on this, so we are basically passing all the IDs of all the rows that need to be dropped. And then we are saying that we are doing this in place. So that is going to remove the rows from this same surveydf data frame and not create a new data frame with the removed rows, right? There's a lot to unpack here, and the way to solve it would be to just take each expression and run it on a different line, on a different code cell, and see the results and build it step by step. Or you can also follow this link here, which explains this entire line of code. Or you can just check the documentation of surveydf.drop. Okay. So with that, we've done this for age less than 10. We've removed those rows. Age greater than 100. We've removed those rows as well. And the same holds true for work week hours. So here, if you check the work week hours, it seems like the minimum is 1, which seems reasonable. Some people might be just working for 1 hour a week, but the maximum seems to be 475. And that's probably wrong because the number of hours in a week is about 168. All right. So we can take another approximation here that let us remove all the rows where the value for the column of work week hours is higher than 140 hours, which is about 20 hours per day. So now you have surveydf.drop, and here we are dropping the rows where the work week hours are more than 140. The gender column also allows picking. So there's the gender column. So if you see, there's a column called gender. If we just check schema.gender. So here the question was, which of the following genders describe you? And please check all that apply. So this gender question about gender allows picking multiple options. So here we have man, woman, non-binary, genderqueer, or gender non-conforming. So these are the 3 options, but there are cases where people have picked multiple options too. So for instance, there are around 121 people have picked man and non-binary, genderqueer, or gender non-conforming. Now, while this is acceptable in general, it is going to make our analysis a little bit difficult. So we are just going to do a small simplification here. We are just going to take all of these values where none of the values have been selected, or where multiple values have been selected, or all the values have been selected, and simply replace these with empty values. So the reason we're doing this is that it's going to simplify our analysis just a little bit. So let us so what we're going to do is we're going to replace all of these with the empty value. So that's going to simplify our analysis to just looking at one category at a time. Okay. So I'm just going to do this. You can follow this line of code. So we're calling surveydf.where, and surveydf.where takes a condition, and then based on the condition, wherever the condition is satisfied, it replaces the value with a specific value that we are providing here, and you can do it in place. Okay. So I will leave this as an exercise for you to figure out on what exactly this does, but the end result of this is to take surveydf gender, and now when we check the value counts, we only have a single option being selected: man, woman, or non-binary. Okay. And that's just for simplification, not to say that any of these options are invalid. So with that, we have now cleaned up the dataset and prepared it for our analysis. We've made a few assumptions, we've made a few simplifications, we've removed certain rows, we've replaced certain values with empty values, and this is a typical process that you will follow for any dataset, any real-world dataset that you do. The lesson here is not to jump immediately into analysis. Just first go through these values, see where the missing values are, see if you need to do something about the missing values. So for strings, not really, but sometimes for numbers, you may want to do some kind of a replacement for the missing values. Sometimes you may want to simply remove those rows altogether. We've not done that in this case. Deal with any invalid values, any values that you feel are outside any normal range. You should get rid of those rows entirely, or maybe simply clear out those values with just the empty value, and a lot of things like that. And then finally, we've now cleaned up our data frame, so we can just check a sample. So I'm just calling surveydf.sample with 10. So just to see a random sample of 10 rows. And this is again a very good exercise to do. Just go through some sample data from your dataset just to get a sense of what the values in each column and different rows look like. Okay. So here we can see that the countries, it looks like they're strings, and then the age seems to be, okay, seems to be a number. There are also places where people have not filled the age. Then we have the gender. Remember, we've done a simplification here where we've reduced it to just one answer. And then we have the education level. Then there is the undergraduate major and so on. So just going through each columns is going to help you make better inferences on the data. And with that, our data pre-processing and cleaning is complete. So let's just commit our work once again. So moving forward, now, before we can ask any interesting questions about the survey responses, it would be helpful for us to understand what the demographics, which is things like the country, age, gender, anything that you can use to pick out groups from the responses, any such information, what the demographics of the respondents look like. And it's important to explore these variables mainly in order to understand how representative the survey is of the worldwide programming community and of the worldwide population in general. And this is again, the reason this is important is because a survey of this scale generally tends to have some bias. So in the world, there are a certain number of people who are programmers. Out of those programmers, a certain fraction use Stack Overflow, and that's not a randomly uniformly selected fraction. So there's already definitely some selection happening there. Out of those who use Stack Overflow, a certain number of people have taken the survey. So once again, that is not a uniform selection from the entire user base of Stack Overflow. There's probably some selection bias here. People who are more likely to take a survey are probably also people who are, let's say, have 3 or 4 other qualities. So it's not a random sample, completely random sample. And then there's also how Stack Overflow publicized the survey, what was the outreach process, and all that decides who saw the survey and who filled the survey. And also like the language of the survey, the kind of questions that were asked, the length of the survey, all of these things make a big difference in terms of who has actually filled the survey. And all this is called selection bias, where the respondents of a survey do not come from a randomly picked sample of the overall population that you want to study. So do keep that in mind, and that's why it's important to first look at the demographics. Okay, so we are going to do what is called exploratory analysis and visualization, where we don't really have a question in mind. We are simply looking at different rows, columns, comparing things, plotting graphs. And since we will be plotting graphs, we will be using matplotlib and Seaborn. So here what I'm doing is I am importing matplotlib and Seaborn, and I've set some basic styles. Like I've used the dark grid style from Seaborn. I have increased the font size and the figure size for matplotlib so that we can see the figures a little more easily. Now, if you want to understand what all of these mean, I will refer you back to the previous lecture on data visualization with matplotlib and Seaborn. Okay, so with the imports out of the way, so let's first look at the number of countries from which there are responses in the survey, and maybe plot the 10 countries with the highest number of responses. So there was a question, where do you live? And so the column name for that was country. So we just see that from the schema, country corresponds to where do you live. And from the survey data frame, if we just get the country column and then call .n unique on it, so that's going to give us the number of countries that are there in this data set. So respondents from 183 countries have answered questions, and that's pretty good. It's quite wide. But it might be better to look at what the distribution of responses across countries looks like. Now, we cannot plot the entire distribution for 183 countries. So maybe what we'll do is we will simply look at the top 15 countries from where we had the maximum responses. And the way to do that is to take the surveydf.country, the column, and then use .value counts on it. So .value counts is going to, well, let's see what that does. So you can see here .value counts, that's going to take each distinct value on country, so each unique value inside country, and then take that and count the number of values for each one. So here you can see that these are the different value counts. So for each country, we now get back a count, and this is a series essentially. And then from that, and this is going to be sorted. So you can also decide whether you want this to be sorted. So you can set sort equals true, and you can set ascending equals false. By the way, if you want to show this documentation inline for any function that you're using, all you need to do is press Shift plus Tab. So here I'm pressing Shift plus Tab, and that shows me the documentation. Okay, so we have the value counts, and then we pick the top 15 countries out of it. So those are the top countries. You can see here United States at the top, then India, then UK. And it's good to look at it this way as a table, but you cannot really grasp what is the difference visually, what is the distribution looking like. And that is where a bar chart will probably help. So we can use the index of the series as the x-axis, and then we can use the values in this series as the y-axis. So we are going to create a figure here. So I'm just going to set a plt.figure fig size, just to make this a big figure. We're going to set a title for it. So we're going to set the title as the question that was asked. And then we're going to use cbon.barplot. So cbon has been imported as SNS, and we use the bar plot. And for the bar plot, we give an x-axis and a y-axis. So the x-axis, we are going to use the index, the names of the countries. And for the y-axis, we are going to use the values, which is the number of respondents from each of these countries. So there you go. Now you have the graph. Now, before we analyze this, I just want to say by default, these labels are printed horizontally. And if we do print them horizontally, there will be a lot of overlap. What we've done here is we've called the plt.xticks function, and we've set rotation to 75. So that has taken these labels and then rotated it 75 degrees. And because of this, now you can see that they're slightly slanted and we can all read them. Okay, so now we have the graph. So looking at the graph, it seems like a disproportionately high number of responses came from United States and India, right? So the United States has 12,000 responses, and then India has 8,000, which is about only about 75% of the number of responses from the US. And then next is United Kingdom, which is less than half of India. All right. And that already tells you that probably this survey is not really representative of programmers around the world. Maybe a large 12,000 plus 8,000 plus 4,000. So that's about 24,000 out of 65. So that's about more than 1/3, more than 40% of the responses have come from these 3 or 4 countries. And you might, if you think about this a little bit, it makes sense because one, this survey is in English, so it was only conducted in English. So therefore, the programmers from non-English speaking countries probably did not get to hear of it. Second, Stack Overflow's user base is, Stack Overflow is also a platform that is completely in English. So its user base is primarily from countries where English is spoken in different professions. And those happen to be the top 3 countries: United States, India, and United Kingdom, where we speak English on a day-to-day basis in our professional lives. Okay, so that's something to consider, that the survey may not be representative of the entire programming community, especially the non-English speaking countries. And it's something for Stack Overflow to consider. Maybe they should try translating their question and answers into different languages, and maybe they should also translate their survey into different languages so that they can get a more representative result. Okay. Now there's an exercise for you here. What you can do is you can try finding the percentage of responses from English speaking versus non-English speaking countries. So here I've linked to a list, a CSV file, which contains the list of languages spoken in different countries. See if you can combine that data with this data to create a new column that says English speaking, and maybe it contains yes or no or true or false for the English speaking column. And then see if you can see how many responses are from English speaking and how many are not. Okay. So that was about the different countries the data came from. Probably the next thing that we can study is the distribution of the age of the respondents. So the age is another important factor to look at. And this time, because age is numeric, we can probably use a histogram to visualize it. So we are going to use plt.hist, and let's just check what the question about age was. So the question was, what is your age in years? And a lot of people may have preferred not to answer this question. Fortunately, what happens is when we use these matplotlib and cbon functions, any empty values are automatically ignored. So now we have So we are calling plt.hist, and then to it we are passing the surveydf.age. So this is the column containing the age values, and these are all numeric, remember. So then we are also going to set a number of bins. So what we want is we want to take the ages starting from 10, because we've removed everything below age 10. So we want to start from 10 and we want to go up to 80. You could also go up to 100 if you wish. Let's maybe change that to 100. And we are going to split this entire range of 10 to 100 years into ranges of 5 years. You could split this into ranges of 10 years as well, but we'll split it into 10 years. And then we will count the number of responses in each age group. Okay, so this is what the chart looks like. So it seems like that there are very few responses below 15 years of age, and a little over 2000 above 15 years of age. But the maximum bulk of the responses seem to be in the range of 20 to 45 years. Maybe you could say 15 to 50 years. So that seems to be the sort of the professional lifespan of a programmer to a large extent. But on the other hand, you can still see thousands of responses beyond the age of 45 and 50. It's common that a lot of people tend to fall into this age range of 20 to 50, but on the other hand, you have people from all over, all the way going up to close to even 80 years of age. Okay, so that's good. Now we understand the distribution of age, and roughly this is representative of the programming community in general. Especially since a lot of young people have taken up computer science as a field of study or a profession in the last 20 years, right? Colleges now have computer science degrees. The number of jobs in computer science have increased, and most new jobs tend to be taken by younger people, and most new degrees as well. So that's why it is slightly representative, and you can do some research on how exactly representative it is and which age groups are left out. And here's an exercise for you. You may also want to just create specific age groups like 10 to 18 years, 18 to 30 years, 30 to 45, 45 to 60, and so on. And you may want to create a column called age group, which will contain, based on the age, it will contain one of these values. And then what you can do is you can repeat the analysis in the rest of this notebook for each age group. If you just want to pick out your age group, let's say you're in the 30 to 45 age group, and you just want to know what programmers in your age group think, then you can just do this analysis for your age group, and that will be an interesting thing to try out. That's a project idea right there. Then let's look at the distribution of gender. We've already done a small simplification here where we've excluded multiple responses. And now it's a well-known fact that women and non-binary genders are underrepresented in the programming community. So we might expect to see a skewed distribution here. So if we do schema.gender, here it looks like the question that was asked was, which of the following describe you, if any? So people were open to leaving it blank. And then we have the gender counts. So now we are taking surveydf.gender and then using value counts here. And already you can see that there is a huge drop. There are 45,000 responses from where people have selected man as the gender, and there are about 3,800, only 3,800 values where people have selected woman. And let's also include in value counts, you can also include drop NA equal to false. What that does is that also tells you how many people have picked nothing, no value. So now what we can do is we can use a pie chart to visualize this distribution. So once again, we take these gender counts and we use plt.py, and we can then give it an index. We can give them some labels as well, and we can give the chart a title. So here you go. Now it seems like around 71% people have picked man, only about 6% have picked woman, and only about 0.6% have picked non-binary, genderqueer or gender non-conforming. And if we exclude the NaN values, so if we exclude the no answers, so among the people who have answered, it seems like 92%, close over 91% are men. And this number is actually, so that means only about 8% are women or non-binary. And this number is actually a far more skewed than the overall percentage. So the overall percentage of women and non-binary genders in the programming community is estimated to be about 12%. So this number still has some skew. And what this number tells us in general, and even the overall figure, is that there is a diversity problem in the programming community that we definitely, if 50% of all people are women, and then there is a larger number, I think, I'm not sure about the number, but a larger percentage of people also identify as one of the non-binary genders. So we definitely need to have more representation in the programming community, and we should support people from underrepresented communities and encourage them to be part of the programming community. Okay. And an interesting exercise for you now to do would be to compare the survey responses and preferences across genders and repeat this analysis with those breakdowns. So for each graph, maybe instead of for each bar chart, try to show side by side men versus women and see how things differ. So for instance, you could try and figure out how do the relative education levels differ across genders. Do women hold similar degrees in terms of percentage, or do they hold higher degrees? And you may be surprised. How do the salaries differ? That is another thing to figure out. We definitely know that there is a gender pay divide, there's a gender pay gap. So maybe you can discover that, and there's a column which talks about salaries. And then you may find there's this analysis on gender divide in data science, and you may find that useful. That is also an exploratory data analysis project if you want to explore that a little bit. So that was about gender. Now let's talk about the education level. Now, formal education in computer science is often considered an important requirement of becoming a programmer. Computer science is one of the most sought after degrees, and both in bachelor's and in master's. Let's see if this is indeed the case, because on the other hand, a lot of you may have learned programming on your own, and there are many free resources and tutorials available online to learn programming. So what we'll do is we will use a horizontal bar chart to compare the education levels of different respondents. So you can just check here schema.education level. So there's a ed level column. The question was, which of the following describes the highest level of formal education that you've completed? So keep that in mind. This is the highest level. So what we are going to use now is a count plot. So what's a count plot? We can check the documentation. So the count plot shows the counts of observation in each categorical bin using bars. So what that means is, if you check the different values that education level contains. So if we just check if we just check survey df dot ed level dot, let's say, what are the unique values? So these are all the unique values, and the count plot is going to tell us for each of these values how many observations are there, like how many times was this particular option picked, or how many times does this particular value show up in that column. Okay, so we pass to count plot survey df.education level, and you can just do this, but that is going to make vertical bars. And if you just want horizontal bars, you can just pass y equals survey df.education level. So this is what the graph looks like. Maybe we should increase the size of the figure a little bit. So let's just set plt.figure fig size. Okay, this is a lot better. So the question is, which of the following describes the highest level of formal education you've completed? And now you can see here that it seems like out of the 65,000 respondents, about 25,000, over 25,000 hold a bachelor's degree, and then another close to 12,000 hold a master's degree, and then there are a few more which hold a doctoral degree, probably about 1,500 or so. So all of these three combined, it seems over half of the respondents hold a bachelor's or master's degree. So most programmers definitely seem to have some college education, definitely maybe some STEM education, what is called some kind of a STEM education. But it's not clear from just this graph alone whether they hold a degree in computer science. Okay, so let's dig a little bit deeper into that. And one problem with this graph is that here we are showing the absolute numbers, and probably what we really want to understand is percentages. So one exercise for you is to convert this graph to just show percentages instead of the full numbers. Okay, and that will probably give a clearer idea, because we probably want to know, out of the number of people who have responded to this question, what percentage have mentioned that the bachelor's degree is the highest degree that they hold. And that is probably the more relevant question to ask. So you can try and modify this code to just show percentages. Okay, but keeping that aside, we could tell that over half of the respondents hold a master's or a bachelor's degree. All right. So now let us then take and plot the undergraduate majors. So this time we will look at schema.undergrad major, which was what was your primary field of study. And we will then convert these numbers into percentages. So to convert these into percentages, we take the value counts for each of the values. So here we say surveydf.undergrad major.value counts. So for each major, like computer science major, you have 31,000 responses and so on. So what we can do is we can divide that by the total number of responses given for undergraduate majors. So let's just take the surveydf.undergraduate major and call .count on it. So .count is going to count the total number of null values. So if we do that, then you can see that now we get back a fraction. So for each major that was provided here, we get back a fraction, 0.61 and so on. And if we multiply that by 100, we are going to get back a number, or we're going to get back a percentage. All right. So now we have a 61% have computer science, and another 9.3% have picked another engineering discipline, and so on. All right. But it's probably better to look at that using a graph. So we just put this result into a variable called undergraduate percent, and then use sns.barplot to plot it. Okay, so now here we have it. So in terms of the primary field of study, it seems like out of the people who have responded, over 60% say that computer science or software engineering or computer engineering was their major. Now, the one way to know, this is like a glass half full, half empty kind of a situation. The way I would interpret this is that close to 40% of programmers holding a college degree have a field of study other than computer science, which is very encouraging. A lot of people after college feel that you cannot switch your field. That is definitely not true for computer science. If you want to get into computer science and you have some sort of formal education, some sort of STEM education, you can absolutely pursue it. There are so many online resources, like close to 40% of people who are in the domain are from streams other than computer science. So I think this is a very encouraging sign, and I think this number is only going to go higher because there are better and better resources available, and programming is proliferating into pretty much every domain now. So you do a little bit of programming no matter what you study, and that equips you to become a programmer as well. Even data science, for example, is primarily a lot of programming. So what we understand in general is that while college education is helpful in general, you do not need to pursue a major in computer science to become a successful programmer. And one trend that you might have noticed here while we are doing exploratory analysis is that first, every time we plot some graph, there is some background to it. There is a reason why we are exploring a particular column. And this is something that we've explained here, that we want to understand, like the reason we are looking at education level is to understand whether formal education is important or not. So have some background, have something in mind when you are exploring a particular column. And then once you have explored that column, once you have plotted a graph, try to gain some insight from it, try to make some kind of an inference or an observation or a hypothesis based on it. Sometimes you may need to then go do more research to identify if your hypothesis is correct. And in other cases, the inferences can become pretty clear. For instance, in this case, it is pretty clear that a lot of people do not have a computer science degree. All right. And that is the best part of exploratory analysis, is that you get to form all of these interesting inferences. Each time you draw a graph, you learn something new. Each time you look at a column, you learn something new. And then there's an exercise here for you. There's a column called new ed IMPT. Let's see what that column is. So that's, let's see, schema.new ed. Okay, so that column is the question in the column is, how important is a formal education such as a university degree in computer science to your career? So now what you can do is you can take this column and analyze the responses, the distribution of responses for people who hold some college degree for people who hold a computer science degree versus those who do not. Okay, try and analyze these results. So what percentage of people who hold a computer science degree have selected that a formal education in computer science is important to the career, and what percentage of people who do not hold a computer science degree have selected that formal education is important for their career? And see if you notice any difference in opinion. My guess is somebody who holds a college degree may value it highly, but somebody who does not hold a college degree but still become a programmer will probably say that it's probably not that important. So do check it out, do discover there are more insights to be gained here. And then one last area that we will look at is employment. Now, especially among programmers, freelancing, contract work and part-time work is slowly becoming a more popular choice. So it would be interesting to see the breakdown between full-time, part-time and freelance work. So maybe let's visualize the data from the employment column. So the employment column was which of the following best describes your current employment status. And what we've taken here is, once again, we are going to plot a simple horizontal bar chart. And one of the things that I want you to take away from this is also that simple charts are often good enough for a good analysis. You do not have to come up with a lot of fancy charts, although it's good if you can find the best chart for the best kind of graph for every statement for every situation. But even simple bar charts, line graphs, scatter plots can give you a lot of information, right? So you are very well equipped at this point if you've worked through this course. So now we look at the surveydf.employment.value counts, and we are just setting normalize equals true. So when we set normalize equals true, that also gives percentages. And then we're also going to convert, sort it in ascending order and convert that, multiply by 100 to get percentages. So normalize gives fractions, and then we convert that into percentages. And then we use the pandas plotting function. So dot plot, and this, so it's just to show you a variation of different ways of plotting. And we are going to plot a horizontal bar chart with the green color. So now you see that among the people who have replied to this question, employed full-time seems to be about 70%. So 70% people are employed full-time among the respondents, but there are a fair number of students as well. So there are about 12% of students. What you might want to do is you might want to break down, and then there are people who are not employed but are looking for work. And then there are people who are freelancers, part-timers, and then there are people who are just, maybe their hobbies, they're not really looking for work, they're not employed, or they're retired. So you might want to create a new column, employment type, that contains values like enthusiast, which could mean students or people who are not employed but are looking for work. And then professional, which is people who are employed full-time, part-time, or are freelancing. And then other, which is people who are not employed or retired. And then what you can do is you can see for each of these graphs, how do the preferences differ between students and professionals, between enthusiasts and professionals, right? Especially some of the things that we'll do after this, which is analyzing programming language preferences and things like that. So that's a good exercise to do. In any survey, in any analysis, all of these breakdowns offer a lot of insights. And the best way to do it is identify which group you lie in. Let's say you are parsing by gender or by age or by your employment status, and then do the analysis just for yourself and people like yourself. And that is going to give you a lot more insight. Okay. Now, one interesting observation here is that if you take away students, then among people who are employed, it seems like at least 10% of the people are working independently as contractors or freelancers or self-employed. For instance, startup people who are doing startups or running their own companies. And that is pretty encouraging. That's a pretty high number for a technical field like this, to be able to work on your own without being formally associated with any company. So that's a great thing, that it's also a way for you to try and break into the field. If you are looking to become a programmer or looking to break into data science, maybe initially you can try some freelance work, you can try maybe an internship, some part-time work, and that can help you transition into a full-time role. So that's something to consider as well. Now, in terms of what are the actual roles held by the respondents, we can look at the dev type field. So you can see here there's a type, dev type, which of the following describes you, and there are a bunch of different values for the roles that are provided. Now the problem here is that this allows selection of multiple values. So if you just check the dev type.value counts, or let's just do dev type.unique, you will see here that there are a lot of different possibilities. So you can see here that there is a developer, desktop, or okay, let's just try value counts. That's probably a little bit easier. Yeah. So you can see here that There are some simple options that were picked, like developer full stack, just that, and then developer backend. But then there is also, you can select multiple options. So you can select developer backend, and the semicolon indicates that multiple options were picked. So about 3,000 people have picked 3 options: developer backend, developer frontend, and developer full stack. And about 2,000 have picked developer backend and developer full stack. And then there are a lot of people who have picked many different combinations. So it's not really clear even from the data how many options were available, but it seems like this person has picked a whole bunch of different options, and so is this person, and so on. So this is where we might need to do some more processing. Now we might need to take this column, which contains a list of values separated by semicolons, and maybe split it out into multiple columns. Okay, and for that, what we are going to do is we are going to define a helper function called split multi-column that is going to take a series or a column of data which contains list-like values, lists of values. So data like a column like survey.dev type, and split the values of that column into multiple columns. Okay. Now I will not go over the code here, and you can try this. You can try to run each line one by one, and you can try to understand the code. So by this point, I hope that you are well equipped to understand this code. Just run each line on a different cell. If you're not, you can also ask on the forum, and you can have a discussion where you can ask, you can share where you're stuck or which part you don't understand, and you can have a discussion to figure it out. But let us look at the output. So we know what the input into this looks like. So the input into this split multi-column function is going to be a series where people have picked either none, or one or more than one options for their employment type, for their job role. So we can call split multi-columns on survey.dev type, and passing this column returns a data frame. So we get back a data frame dev type df, and if we just check this data frame, it seems like this data frame now has one column for each of the options that were provided for the question. So now we have one column for developer, desktop or enterprise applications. Then we have developer full stack, developer mobile, designer, and so on. So there are in total 23 columns. So there are about 23 options that were given for your job role. And what we have is, for each respondent, we have either true or false. So for instance, for this respondent has not selected developer desktop or enterprise, but this respondent has selected developer full stack, and this respondent has selected developer mobile, and they have not selected developer frontend or backend. All right. So this is how sometimes we might need to do a little more processing of our data. We might need to break one column into an entire data frame so that we can do our analysis. And now that we have this data frame, the dev type df, we can now use this to identify what were the most common roles. Okay. And a simple way to do that would be to simply count the number of trues in each column. And you know that true, when it is converted to an integer, becomes 1, and false, when it is converted to a number, becomes 0. So what we can do is we can simply take the column wise sums. So we can just take dev type dot sum. So we get a column wise sum, and then we can sort those values in a descending order. So that's going to give us these dev type totals. So now you see that we have developer backend, developer full stack, developer frontend, and so on. So those seem to be the most common roles. And it's not surprising that the Stack Overflow is primarily a tool used by developers and professional developers for finding answers to small questions on writing code. So it's not uncommon that the developer role that you see is the most common one. But one interesting thing for you to figure out would be what percentage of respondents work in roles related to data science. And then you can probably also try and figure out which role has the highest percentage of women. So what you can do is you can just filter. Now that you have this data frame, you can then merge it back into the original data frame. So you can create a new merged data frame which contains the columns from survey df, but also contains these columns for each role. And then you can try and find out which role has the maximum percentage of women. Okay, that's an interesting thing to figure out. So with that, we end our exploratory analysis, and we've only explored a handful of columns from the 20 columns that we selected. we've only explored about 5 or 6. So you can explore and visualize the remaining columns. Here you have some empty cells, and you can always add new cells using insert cell below. So please do that. The more you explore, the more you learn. It's possible that while you work through this notebook, you find 5 or 10 interesting columns, and you just want to do a project using those columns, and that's perfectly acceptable. You can use this dataset for your project. Just do not repeat the same analysis that is done here. Do something a little more interesting. And before we continue, let us upload our work. So from time to time, keep running jovian.commit so that you do not lose your work. All right, so now we come to a slightly more interesting part, although I think the exploratory analysis was pretty interesting as well. But now we can ask some questions and then answer them. So we've already gained several insights about the respondents and about the programming community in general, simply by exploring individual columns. But let's ask some specific questions and try to answer them using the data frame operations and using interesting visualizations. Okay. So the first question that we'll ask is, what were the most popular programming languages in 2020? So this survey was conducted in February of 2020. So this is technically 2019's data. But see, so we see schema.languages worked with. So the question asked was, which programming, scripting and markup language have you done extensive development work over the past year, right? So which languages have you used in the past year? But this is a two-part question, and the second part is, and which do you want to work in over the next year? So here the respondents were presented with a list of options, and then for each option they had 2 checkboxes. So the first checkbox they would tick for this part, whether they've worked with it in the past year, and the next checkbox they would tick for this part, whether they want to work on it over the next year. And the responses were then taken, and they were broken into two columns. So we have the language worked with, which contains the answer to the first part, which language have you worked with in the past year. But then we also have the language desired next year, which has the exact same question, but this contains responses to the second part. So I'm showing you this because this is something interesting that, with real world data, and especially with how surveys are conducted, you might often have this, and without the context, you might not understand what's the difference here, because it seems like languages worked with and languages desired next year have the exact same question. So you may want to just go through the README, or you may want to take the survey yourself to understand that, okay, there are 2 parts, and the first part is covered in the first column, and the second part is covered in the second. Okay. So putting that aside, let's just look at what some values in the languages worked with column look like. So it looks like, once again, people could select multiple options, multiple languages. So you can see that the first person has selected C#, and then HTML, CSS, and then JavaScript. So they are separated by a semicolon. So this is similar to the dev type field. So the first thing that we might want to do is just split this into a multi-column. So we just call split multi-column on survey.df.languages worked with. And then we can see the languages worked df. So this is now the data frame where we have 25 columns. So it seems like 25 languages were presented to the respondents. And now for each of those, for each respondent, we can see true, false. So true indicating whether that respondent has used the language, and false indicating whether they have not. Okay. So now going back to the question, what were the most popular programming languages in 2020? So what we can do is we can try and identify percentages, what percentage of people have selected JavaScript, and then what percentage of people have selected Swift and Python and so on, and then plot that as a bar chart. Okay. So once again, to get these percentages, we simply say languages worked df.mean. So this is another way to do it, because true becomes 1 and false becomes 0. So if we take the mean of this entire column, if we take a column wise mean, we get back the percent or the fraction of true values in the column, right? So the mean is simply sum of all the values divided by the total number of values. So since the zeros or the falses go away, that is basically the number of true values divided by the total number of values. And that is essentially the percentage of true, right? So we take or the fraction of true. So to convert the fraction into a percentage, we multiply by 100, and then we sort values in descending order. So that gives us the percentages of each language. So it seems like JavaScript is the most popular language, followed by HTML, CSS, and SQL, and so on. And let's visualize this once again using a horizontal bar chart. So now it seems like the languages used in the past year, once again, JavaScript was the most popular language, followed by HTML, CSS. And this is no surprise because today a lot of software has moved onto the web. Like you probably spend most of your time in the browser. Even the Jupyter notebook platform that we're using is actually running in the browser. And the only way to write code in the browser is, one, you have to write HTML, CSS, and second, you have to write JavaScript for interactivity. Now JavaScript might be higher than HTML, CSS because you can also use JavaScript on the server side using a framework called Node.js. And because of all these reasons, JavaScript is the most popular language because it is the sort of the de facto language of the web. And then we have, so again, now we have plotted this chart, and based on this chart, we can make some inferences, right? Then we have SQL. Now, once again, today, all applications need some kind of a database. And the most popular form of database is what's called a relational database, or what is called a tabular database. So a lot of the data, let's say the data of your Facebook accounts, the data of your Twitter, the data of your Instagram, or any platform that you use, the data that you put into Jovian, a lot of the data is saved in SQL databases. And the way to interact with these databases using the SQL language, and that is why SQL is probably pretty popular as well. But beyond that, if you take away web development and take away database access, the actual application development, like any backend application development or data science, a lot of these other areas, any non-web related development, seems like Python is the most popular language. And this is again no surprise because Python is Python is a general purpose language, and it has beaten out Java. So Java was the de facto language for all development pretty much for about 20 years, but it seems like Python has now beaten out Java. So it's a good thing that you're learning Python. It is definitely an in-demand language. Okay. And there is a whole wealth of information that you can gather just from exploring a little bit deeper into this question. For example, what are the most common languages used by students? And how does the list compare with the most common languages used by professional developers? So is there a gap between what students learn and what professional developers use? You might want to answer what are the most common languages among respondents who do not describe themselves as front-end developers. Because front-end development, you don't really have a choice. You have to use JavaScript. TypeScript is a choice, but it's a small choice. So if you just exclude front-end developers, can you then answer what are the most common languages people use? Can you try and find out what are the most common languages used by respondents who are working in a field related to data science? And maybe also see in terms of age, developers who are older than 35 years of age, or maybe developers who have more than 10 years of programming experience, what are the most common languages used by them? And what are the most common languages used by people who are younger? Do you see a shifting trend? And what are the most common languages used in your home country? That is something that you can try and find out, because there are responses from over 180 countries here. Is there a difference between, let's say, US and India and China and different countries? Then moving ahead, another similar question we could ask is, which languages are people most interested to learn over the next year? So for this, we can use the language desire next year column, which will have pretty much identical processing. So we take the language desire next year and we split it into multi-columns. Then we get percentages for each language once again by taking the mean and sorting the values and multiplying by 100. So you can see here the language interested percentages. These are the values. And let us just jump into visualization directly. The visualization is once again pretty much identical. And it seems like that Python is the language that most people are interested in learning. So we have Python, JavaScript, HTML, CSS. Again, they seem to be close by, and followed by SQL and TypeScript. And it's no surprise that Python is the most sought after language, because it's an easy to learn general purpose programming language, and it is very well suited for a variety of domains like application development, numerical computing, data analysis, and so on. And in fact, we are using Python for this very analysis. So you are in good company. If you're learning Python, you can apply it to a whole host of different domains. What you can do is now you can repeat the same exercises that we discussed for the most common languages. Just replace all of these questions with the languages people are most interested in. So those are some exercises. And you can also, the next question what we'll do is we'll combine these two things. So the question here is, which are the most loved languages? That is, where do you see a higher percentage of people who have used the language and want to continue learning it over the next year? Okay, so this may seem like a somewhat complicated question to ask. Okay, people who have used the language in the past year and they also want to continue learning it, how am I going to figure that out? It may seem a little bit tricky, but it's actually really easy to solve using Pandas using Pandas data frame operations. So here's what we'll do. We will create a new data frame, languages loved df, which has the same structure as languages work df and languages interested df. So again, for every language, it has a column, and then for every respondent, there is a row, and there is a true value only if the corresponding value in both languages work df and languages interested df are both true, right? If somebody has worked in that language in the past year and wants to continue using that language, then we are going to put in a true there. And the way to do that, it's really simple. All you do is you take the languages work df and then you put in an ampersand, and then you pass languages interested df. What this will do is this will do a element wise AND, right? A Boolean AND. So if two values are true, two respective values, then you will get 2. And if you have a true and a false, or a false and a true, or a false and a false, you will get back false. All right, except that this is going to happen on a per element or a per value level. So now we take languages loved df, and then we look at it. So for example, this respondent has true set for C# because this person has worked in C# and they are interested in continuing to work in C#. So that's we are saying that this is a proxy for saying that they love this language. Okay, so let's convert that into percentages. Now we want to take these numbers, and for each language we want to identify how many people love it out of the number of people who have used it in the past year. So we take language loved.sum, and then so that's a column wise sum, and we divide each of the column wise sums by languages worked.sum. So for the column C#, we will count how many people love the language, so how many trues there are in this column, divided by how many people have used the language. And then we are also going to multiply it by 100 to convert it into a percentage, and we are going to sort it in a descending order. And let's take a look at that. So you can see here that we have languages loved percentages. You can see that for each language we now have percentages, and you can see who the winner is here. So the winner seems to be a language called Rust, and let us look at it in a plot. So the winner seems to be this language called Rust. You may not have heard of it, but it is a low-level language for doing systems programming, and it provides the performance of languages like C++, but it provides many conveniences and a type system of some of the best languages, things like Scala and Java and so on. So it's a pretty useful language. A lot of people enjoy using it, and it's interesting to see that a small language with a growing community is one of the most loved languages. And in fact, you can see the hints here. Now, if you see this graph, Rust seems to be used in a very small fraction. So you see Rust here, it's a small fraction of people who use it. It's far smaller than, let's say, JavaScript. But if you look at this graph in terms of people interested in using or learning Rust, it is way up ahead, somewhere at the top, right? Almost close to about a third, or maybe higher than a third of JavaScript. So it definitely seems to be a language that's gaining a lot of popularity and a lot of interest. So maybe if you're looking for a new language to learn, Rust may be a good choice. And this metric that we just calculated is something Stack Overflow calculates every year based on their survey results. And Rust has been Stack Overflow's most loved languages for 4 years in a row, followed by TypeScript. And TypeScript again is a language that offers an alternative for web development. So these are things that you should do. That once you get an answer, once you get a graph, maybe just search online on why the result might be such. So you can learn a little more about Rust and TypeScript. Now, what I find probably even more interesting is that Python features at number 3. despite already being such a widely used language. And that's generally not true for widely used languages. If you see JavaScript in terms of the love score, it's fairly low and Java is far lower, whereas Python has remained at number 3, right? So it seems like people who use Python enjoy Python, and that is because the language has a solid foundation and it is really easy to learn and use. I hope you've been able to learn Python. You can now say that you're comfortable with Python in just these 6 weeks. And then it has a strong ecosystem of libraries for various domains, and it has a massive worldwide community of developers, and that now includes you and me, so who enjoy using it. So I've been using Python for the last 12 years. I definitely want to continue using it for the next 12 as well. And I hope you feel the same way. So that's about the most loved languages. We now have some insights about that. The next, a simple exercise that you can try here is to identify the most dreaded languages, which is languages which people have used in the past year, but do not want to learn or use over the next year, right? There's a small hint here. What you can do is you can simply invert the language's interested data frame. So and the way to invert it is using this tilde operator. So just invert that data frame and then do the same thing that we did here. So you should be able to answer the most dreaded language, and then see if your results, you get the same result as what the Stack Overflow results present. So you can always refer to them. So moving further along, next question here is, in which countries do developers work the highest number of hours per week? Okay. Now to do this question, we will need to use the group by function of a data frame, the group by method. And there's a small caveat here. We only want to consider countries with more than 250 responses, because otherwise it's not really representing an average, because there are definitely lots of countries with thousands of responses, and we are setting a threshold of 250 so that if there's a country where only 10 people have responded, we are not going to consider it in terms of to get the average number of hours per week. So we take survey DF and we group it by country. So what this does is it takes for each value of country, and there are 184 values. We take all the rows which have that country related to that country and then separate them out into groups. And so far we've not performed any operation, so you don't see any result here. Now for each of these rows, the column that we are interested in is work week hours. So we select the column work week hours, just as we select the columns of our data frame. And just as an example, let's select the age column as well. So now once again, from these, for each of the groups, we have all the rows, and from these rows, we've only selected the work week and age columns. And now we need to aggregate them. So one way to aggregate them could be using a mean. So if we use a mean, then we can see here that work week hours and age. So we will get back a new data frame where now the index is the name of the countries, all the different unique values in countries. And then the values for work week hour and age are the averages from those groups. So all the rows from Afghanistan, we've taken an average of the work week hours and put that value here. Similarly, all the groups from Afghanistan, we've taken the age, and all the rows from Afghanistan, we've taken the age and we've put in the average value here. Okay. So this is how you group by, and you can learn more about this in the Pandas lecture, which is lesson 4. Now what we want to do though, is we want to only look at countries which have more than 250 responses. So the way we're going to do that is, first we're going to create a countries data frame. And this is exactly what we just did, group by country, but just keep the work week hours and take the mean and then sort to aggregate and then sort by work week hours in a descending order. So that's a country DF. Okay, so you can see that these are the countries with the highest, these are countries with the lowest, but it's possible that a lot of these countries, probably the number of responses is really low. So what we will do is we will create a new data frame called high countries DF, where we will take these, where we will only select the rows where the value counts are greater than 250. So we are getting survey df.country, and we are trying to find the value counts of each country, the number of responses from each country, and then we are filtering out those only where the responses are greater than 250. And then we use the .loc.loc function to pick values from the countries DF, with only value counts greater than 250, and then we pick the top 15 out of those. So let's see now. So now we have the top 15 countries. Okay. And once again, if you do not understand this, there are a couple of things you can do. Revise the Pandas lecture. That's one thing you could do. Look at the documentation of countries of .loc, and split this into small parts. So first take this surveydf.country.value counts, run it in a cell. Take that and compare that with 250 and see what the result of that is. And then put that into countries.df.loc and see what the result of that is. And then add in the head. So with all of these things, it's a question of breaking them down step by step. And then the more you break them down, the more you understand and the more you will be able to use them. So now we have the high response countries. And these are the 15 countries with the highest number of working hours. It seems like some South Asian countries, some Asian countries like Iran, Israel and China have the highest working hours, which is followed by United States. So that's interesting. And then we have Greece. So people are probably working a lot. Programmers are working a lot in Greece. And once again, we see a bunch of Asian countries all the way till actually a majority of these seem to be Asian countries. And then there are a few European countries and then there is United States. But overall, there isn't too much variation. If you see 44 is the highest value. If you just take the first three as outliers, then here you have 41 to 40. So on average, there are only about people are working at about 40 hours per week. There's no variation where there's a country with an average of 60 hours or a country with an average of 20 hours. At least it seems like so from the top 15. So now a few exercises that you can try is try to compare how the average working hours compare across different continents. So you may find this list of countries in each continent useful. Try and find out which role has the average number of has the highest average number of hours worked per week out of all the developer or out of all the roles that we looked at. So you may need to merge with the dev type data frame that we created, which had one column for each role, and try to find out maybe how the hours work compare between freelancers and developers working full-time. Well, full-time developers, it's possible that you might find that the average is around 40. But freelancers, one of the reasons people take up freelance or even part-time work is because they want free time to work on other things. So let's try and verify if this is true. Do freelancers work less or more? And that could help you maybe even decide if you want to choose between a freelance or a full-time role. Okay. And then let's ask one more question. How important is it to start young to build a career in programming? Okay. And this is again something that is a question that a lot of people wonder, not just about programming, probably about data science and in general about any field. Can you enter this field, let's say beyond, if you've not done it in college? And I think we've established that even if you've not taken it in college, you can still enter the field. But can you enter the field if you've worked in a different domain for a few years? Can you enter this field in your 30s, in your 40s and so on? Okay. So what we'll do to answer this question is we will create a scatter plot of age versus the years of coding experience. So there is years code pro is asking, not including education, how many years have you coded professionally as a part of your work? Okay. So what we'll do is we'll plot age on one axis, on the x-axis, and then we'll plot the years of professional coding experience on the y-axis. And that should maybe give us a hint. So here is a chart. And this is what it looks like. Now, if you look at this, it seems, let's look at some values and let's try to understand this chart. And we've also put in colors here and we'll touch that in just a moment. But if you see here in let's say you're looking at age 40. So at age 40, there are several people who have less than 10 years of programming experience. And there are even, so at every age, all the way from around 15 to even close to 50, there are people who have just started working as programmers. So what that means is that you can start programming professionally at any age. There's no restriction that you have to start early. People are starting in their 20s, in their 30s, in their 40s, and everybody is welcome. And this is professional experience. This is not just programming experience in general. So you can, if you put in the work, if you learn, if you're open to learning, if you're excited about it, then you can definitely get into the domain. And then we have also added a color for each of these dots. So each dots represents one response. So we've added colors. So the color we've added is, if a person is a hobbyist, then we represent them with blue, and if not, we represent them with orange. And once again, it turns out that a lot of the people who are programmers also say that programming is a hobby for them, and especially so in the initial years. So in the initial years, to get through the initial years, it will really help for you to just have programming as a hobby, something that you do just to build things, just to solve problems, just something that you do on the weekend. And if you do that, then you will probably also have a long and fulfilling career in programming. So these are some inferences that we can draw from this scatter plot. We can also look at the distribution of the age first code column. So just to see when people have tried programming for the first time. And as you might suspect, a lot of people have some exposure to programming. Maybe they've written a first line of code, maybe a simple HTML page, or maybe just a hello world program. And Python's hello world is just this, right? So you can just type Python into a terminal and you just say print hello world, and that's your first program. But that by itself tells you what programming is. So it seems like a lot of people have been exposed to programming in their teens, and it depends on pretty much every field. You end up writing some code. So in Excel you write formulas, in different streams of engineering you probably use MATLAB or maybe some kind of a numerical computing package. Of course, in computer science, you write programs. If you're doing right now, in pretty much every field, there is some code that you're writing. So it's not surprising that people get some exposure to programming at an early age. But then there are also people who have experienced this after a certain age. Like you can see a lot of people doing so after the age of 30 and after the age of 40. And there is like a small number of people who have even become exposed to it all the way up to the age of 80. So there are people from all ages and walks of life who are learning to code. Okay. Now, here are a few questions that you can try and answer. How does the experience change opinions and preferences? So maybe what you can do is you can repeat the entire analysis while comparing the responses of people who have more than 10 years of professional programming experience. Like which languages do they use? Which languages do they want to learn? With those who do not have that, and this is going back to like students versus professionals. Now you can have three categories: students, professionals, and experienced professionals. And do you see any interesting trends? Do you see what one might call a generation gap in terms of the coders from the old days versus people who are learning it right now? What kind of roles do they occupy? What kind of languages do they prefer? And maybe you can also try and compare the years of professional coding experience across different genders, just to see if, and my guess is you might see that, although minorities are underrepresented right now, there are very few women, but my guess is you will see that there are more women now than there used to be earlier. So it's definitely things are improving, and you can try and validate that. So that's one way, if you can try and compare the years of professional coding experience across different genders. So with that, we have barely scratched the surface here. We have almost been talking for about 90 minutes, and we've already gotten a huge load of insights. And hopefully you're thinking of many more questions that you would like to ask and answer using the data. We've not even used all the 20 columns, only about 12 or 13 columns have been used. And then there are another 45 columns to pick from. So you can use these empty cells below to ask and answer more questions. So I'll let you try out, and you can try out all of these exercises. So there's really no end to this. The more you do, the more you experiment, the more you exercise these skills, the better you get at it. Now I've used fairly simple charts. I've not done many breakdowns. I wanted to leave that as an exercise for you, but try and replace each chart. So each chart or each graph that we have, try to use a different kind of graph, and maybe go through the Matplotlib gallery, go through the Seaborn gallery, and try and pick which might be an interesting graph to draw there. So these are all different exercises for you to try. Data analysis by itself is, there's a lot of depth in the field, and you can probably spend at least a few months just exploring different ways to slice and dice and analyze and visualize the data. So please do that. Okay, the best way to learn is by doing. Now, what we'll do is we'll just summarize some of our inferences and conclusions, and this is always a good thing to do at the end of your analysis. So here's some of the summaries. Like, based on the demographic data, we can infer that the survey is somewhat representative of the overall programming community, although it definitely has fewer responses from programmers in non-English speaking countries and from women and non-binary genders. We have also learned that the programming community is probably not as diverse as it can be in terms of gender, in terms of age, maybe in terms of the different languages or the different countries that are there. So we should probably take more efforts and support and encourage members of underrepresented communities. And race is another thing that we've not looked at, but that's another factor where there's a lot of disparity. And we've learned that most programmers hold a college degree, and although a fairly large percentage of them did not have computer science as their major in college. So a computer science degree isn't compulsory to learn to code or to build a career in programming, but some STEM education definitely helps. And a significant percentage of programmers either work part-time or as freelancers. 10% is actually a pretty good number. And this can be a great way for you to break into the field, not just in programming, but also in data science, which are very closely related fields. We learned that JavaScript and HTML are the most popular programming languages used in 2020. And then we learned that Python is the language most people are interested in learning. And we've learned that Rust and TypeScript are the most loved languages, both of which have small but fast growing communities. And finally, it seems like programmers around the world seem to be working on 40 hours on average, but there are slight variations by country. And finally, we learned that you can learn and start programming professionally at any age, and you're likely to have a long and fulfilling career if you also enjoy programming as a hobby. And especially it's going to help you during the first few years. All right, so that's our analysis. And as I said, there's a wealth of information to be discovered, and we've barely scratched the surface. So there are a few more ideas that I wanted to share with you. You can repeat the analysis for different age groups and genders and compare the results. Specifically, try and pick a slice of responses that represents you, right? So maybe the country you're from, the gender, the age group that you're in, and try and see what the preferences of people are and see if that reflects your opinions too. Try and choose a different set of columns. We've chosen 20 out of 65 and we've used about 12 of them. So you can look at a lot of the other columns, go through the README, go through the survey. Prepare an analysis focusing on diversity. So identify the areas where underrepresented communities are at par with the majority. So you might see that in education, actually, there's probably not a big difference in terms of the percentages of degrees that are different degrees held by people. But then there are places where there are differences like salaries. You will see that there is definitely a pay gap, and you can try and validate that. And try to compare the results of this year's survey with the previous year and identify some interesting trends, because this is data that you get every year. And once again, you can go back to this link, stackoverflow.com, insights.stackoverflow.com, and you can download the raw data for every year. Now, one interesting exercise for you to do is to see the survey results. So you can see that this is a pretty long analysis that they've done a whole bunch of analysis on pretty much the similar questions that we have answered. So see the survey results and try to replicate the survey results graph for graph, right? This could be a great way for you to just see if you are doing the same kind of data cleaning and analysis and simplifications, and see how that affects your results. Now, if you can replicate all of these results, now that's a great sign that this is real world data and this is a large data set and this is a real analysis. So that's a real sign that you've done something significant in data analysis, and you can proudly then showcase that on your professional profile. Then we have this, I just want to share a few references. Now, we've used Pandas, Matplotlib, and Seaborn, so you can refer to the previous lectures. We've linked, you just go to 0topandas.com and you can find the lectures there. You can watch those lectures, or you can also just go through the documentation and the user guides. So you have the Pandas, Matplotlib, and Seaborn user guides. Also go through galleries on Matplotlib websites. So these galleries will show you all the different types of charts that you can create using these libraries. And finally, as I told you, we are creating this open datasets library Python package, which is a curated collection of datasets for data analysis and machine learning. So far we have about 6-7 datasets, but we are planning to add about 100 datasets here. So over the next few days, and we've released this library just yesterday. It's something that we worked up quickly to make sure that it's easy for you to download these datasets. So we are going to add about 100 datasets here. So you can use these 100 datasets for your course project as well. Okay. And that is the next step that I want to talk to you about. Now we've looked at this. What we saw today, the exploratory data analysis, is basically what you need to do on your course project. So you simply need to repeat this. You can repeat it with the same data set and ask different questions, do different analysis, pick different columns, or you can pick a different data set. So let's open up the course project page. And then the objective of the course project is exactly similar to what we did today. You find a real world data set of your choice. You use Numpy and Pandas to parse and clean and analyze the data. And you use Matplotlib and Seaborn to create visualizations. And then you ask and answer interesting questions about the data. And an optional but highly recommended step, because you've put in so much work, and if you can just consolidate all of your learning into a blog post to showcase your work, that is something that you can do as well. So I just want to give you a quick overview of the course project. And then we have a few exciting things to close out. So now the course project, this is a starter notebook. And by the way, we've done a walkthrough of the course project in last week's video as well. So you can just check that out too. So on the course project, you can take the starter notebook and just run the starter notebook on Binder. And you can also run this starter notebook on your local computer. So you do not have to run it on Binder. So I just want to show you how to run it on your computer. So here I have a terminal. Let me just zoom in a bit. Yeah, so here I have a terminal, and this would be a terminal or a command prompt or an Anaconda prompt that you would need. And if you want to download this to your local computer and run it locally, then what you need to do is click on the clone button. So click on the clone button and just paste that command. Now you will need to run this command, but then to run this command, you need the Jovian command line tool installed. So actually I'm just going to skip that command, and I'm just first going to run pip install Jovian upgrade. So that's going to upgrade the Jovian Python library for me. And once the Jovian library is installed, you can see that we now have this command line tool called Jovian that you can use. So now once again, I can copy this clone command, come back here, run Jovian clone, and just simply the title of the project. So username / the name of the project, and press enter. Now that is going to download the files. So you can see that these files got downloaded to my desktop, the Zero to Pandas course starter. If you wish, you can change the name of this folder. So let me just, let's say I'm going to analyze the state of JavaScript survey. So I'm just going to call this state of JavaScript 2019. This is the data that I'm going to analyze for my project. So then I go into this folder, state of JavaScript 2019. Now here you need to install all the different libraries, and we suggest installing these libraries inside an Anaconda environment. What you can do is you can manually create an environment. So conda create -n, and then simply give it a name. So let's say course project, and you can set a Python version for it. So these are the same instructions that are provided in each lecture notebook. So let's just create let's create a Conda environment here. So we've called Conda create -n course project. So that's going to create a Python environment where we can install all our libraries. Okay, so now the environment has been installed. Then we are going to activate the environment. So here we now run conda activate course project. So now the environment has been activated. Inside this environment, we might want to install all the libraries that we want to use. So we're going to use Jovian, we're going to use Jupyter. Let's say we'll use open data sets, or you don't have to, but you might. We are going to use Pandas, we are going to use Numpy, and we are going to use Seaborn, and we're going to use Matplotlib. So we just install all the libraries after activating the environment. And once these libraries are installed, let's just give that a second. Yeah, sometimes this might take a while for you to install. And this is one of the reasons we recommend using Binder, because all of these steps are taken care of for you. So once these libraries are installed, we can now start a Jupyter notebook by typing Jupyter notebook. Okay. So once again, a quick recap of what we did. The first thing that we did was we installed the Jovian Python let me just come back here. I'll open this once again. So once you run Jupyter Notebook, this will print out a URL for you, which you can open up on your browser. But a quick recap, the step 1 was to install the Jovian Python library. And of course, you also need to have Anaconda installed. So make sure that you have the Anaconda distribution of Python installed too. Step 2 is to then clone the notebook using the Jovian clone command. Step 3 is to enter the directory and create a Conda environment. So that is done using Conda create. Step 4 is to activate the environment and install all the libraries. So you say Conda activate the environment name, and then you install libraries using pip install. And then step 5 is to just open up the Jupyter notebook. So by typing Jupyter space notebook. So that's going to print this URL. So you just take this URL here and open it in your browser. And now you can see here we have the 0 to pandas course project.ipynb file. So now at this point it is pretty similar to the place that we get to when we click the run button and click run on binder. So run on binder is a one-click experience, that's why we recommend it, but with a few more steps, and I think now you are familiar with these steps. Now you are I think you're comfortable enough that you can figure these things out. If not, you can always ask on the forum. So with a few more steps, you can run it on your local computer. Okay. So now we have this 0 to course pandas course project file, and the first cell is a text cell, the markdown cell, and you can remove this cell before submission. Now this cell describes what you need to do. It gives you the guidelines. So the first step is to select a real world data set. So you have to find and download an interesting real world data set. And we have given some recommendations for data sets here. If you see this forum topic on the recommended datasets for the course project. So we have given you links to many places from where you can download datasets. For example, there is Kaggle, there is the UCI machine learning repository, there is a GitHub, there is this GitHub repository which has a list of datasets. And now of course we are sharing this open datasets library with you. We will be adding more datasets there. So there are a lot of places from where you can get datasets. And we've also picked out some interesting datasets for you that you can download and use. So today we've used the Stack Overflow developer survey, but there's also the COVID-19 data. This is updated on a daily basis. There's a state of JavaScript survey, and then there is stocks data, and then there is countrywide COVID data. There is some agriculture data. There is data science job data. There is sports data. There is games data, video game data. So there's a lot of interesting data to analyze. And then of course there are a lot of places where you can download your own personal information as well and analyze it. So please go through this list and try and identify something that you find interesting. So anyway, you take these data sets and then you have to make sure that this data set contains tabular data, preferably CSV, JSON or Excel files, that it can be read using pandas. Then you perform some data preparation and cleaning just as we did. So you load up the data frame, you look at the number of rows and columns, you decide which columns you want to use, you decide how you are going to handle any missing or invalid data. Maybe you might want to parse some dates, like we parse some numbers. You might want to create additional columns. You might want to merge multiple data sets. Then you need to perform exploratory analysis and visualization. So this is exploring the distributions of numerical columns using histograms, using bar charts to visualize categorical columns, using his scatter plots to see distributions across multiple columns, and take note of interesting insights from this analysis. And then also ask and answer questions about the data. So you have to ask at least 5 interesting questions and answer those questions by either computing the results using Numpy, Pandas, or by plotting graphs using Matplotlib or Seaborn. And wherever you're using any library function, just explain briefly what it does. It's always helpful for the reader. And then finally, take your inferences and summarize them and write a conclusion. So this is a really important part of consolidating everything you've learned into a single paragraph or a single section. And also share ideas for future work on the same topic using the same dataset or maybe other relevant datasets. And make sure to share links to any resources that might be helpful for people reading your analysis. So definitely share links to documentation, maybe share the link to the course page so that people who are not familiar with Pandas or Numpy can use that. And then the last step is to make a submission and share your work. So whether you're using Binder or you're running on your local computer, from time to time you need to run jovian.commit. So you just set a project name. So for instance, my project name would be, let's say, state of JS survey 2019 analysis. Set a project name and then use the Jovian library to run jovian.commit and commit the project. And that's going to take this either from Binder or from your local computer and put this onto your Jovian profile. So you simply take this link then, and then you need to take this link and go back to the course project page. And on this page, you need to put in the link and click submit. So once you do that, you will see it showing up in your submission history. So make sure that this is a jovian.ml link. So this should not be a local link. Don't put a localhost link. Don't put a Binder link. Don't put a Kaggle or Colab link. Please commit to Jovian and put up a jovian.ml link, and make sure that that link is to a notebook hosted on your own profile. Otherwise the submission will be rejected. Okay. And what we will do is then we will evaluate your project. So what does the evaluation look like? So here we have shared the evaluation criteria as well. So we will evaluate that your dataset contains at least 3 columns and 150 rows of data. You must ask and answer at least 5 questions about the dataset. Your submission should also include at least 5 visualizations, and your submission should include explanations using markdown cells apart from just code, right? So just code is not good enough. Please write explanations, and that helps you understand your data, that helps you gather insights from your data, and it is also going to help others. Like tomorrow, if you want to showcase this project on your public profile, or you want to share it on LinkedIn or wherever, or you want to link to it from your resume, you want to make it nice. You want to show that you've put in work, you are presenting it well, because presentation, believe it or not, is a very important part of data science. So do not skip that. It's not just about writing code. It's about gathering inferences and presenting them and making interesting observations and maybe making hypotheses and digging deeper. So the data tells you just some facts, but you have to analyze it and really come up with what those facts mean and infer them, right? In the context of either the dataset itself or for your company or whatever you're working on. And finally, your work should not be plagiarized. So do not copy paste from somewhere else. Of course, you can borrow functions, and every dataset has been analyzed by many different people. So you can do this analysis which people have already done. You can even look at those notebooks. You can look at notebooks by other people, but do not plagiarize. And I think you will be able to tell best if you are plagiarizing. So as such, the entire project should not be a copy paste. And the biggest loser in that case will be you yourself if you're basically copy pasting stuff. So please don't do that. Now, apart from doing that, do share your work online. So this is a lot of effort that you've put into this project. So please share it on your social media. You can just share the jovian.ml link. Once you've committed it to Jovian, you can simply, once you've committed it to Jovian, you can simply use the share button and share it on any of these platforms. Share your work on the forum as well, because there are tens of thousands of course participants. So we would love to see thousands of projects being shared on this thread. So do share your work on the forum and browse through projects by other participants and maybe give feedback. And that will also be a great way for you to learn. When you see other people creating visualizations, similar or different visualizations, you will get to learn from their code, you will get to learn from their analysis and so on. So please do that. And one highly recommended step is to write a blog post. And a blog post is a great way to present and showcase your work. So you can sign up on medium.com to write a blog post for your project. It's really simple. You just sign up and then you click new story and you can just start typing. And you can simply, as a starting point, you can simply copy over the explanations from your Jupyter notebook into your blog post. And in terms of the code and the graphs, you can actually embed them. So you can take your code and graphs from your Jovian, the notebook submitted to Jovian, and you can embed them within your blog post. So you just watch this video for a quick tutorial or just follow this guide. So you can see here that this is a blog post on Medium, and inside it is embedded a code cell. Or you can even embed an entire, you can embed even like some code and the outputs, like things like graphs, or you can only embed just the graphs if you want to see it. So the benefit of writing a blog post is that it with Jupyter, it contains a lot of code and contains a lot of pre-processing steps, but on your blog post, you can decide the narrative, and you can simply use the right code blocks, and you can use the right write graphs from your Jupyter notebook, and you can embed them within your blog post to tell the story that you want, right? It doesn't have to follow the same structure as the Jupyter notebook. And it will be a great thing to showcase on your profile. It will be a great thing to share on your social media, put up on your resume, or just mention while you're applying for an internship or things like that. And you can check out our Medium publication. We've linked to it for how to write a good blog post. There are many good examples. All of these have been written by people from the community, and this was during a previous course. And in fact, all of these are, in a lot of these cases, these were the first or the second blog post written by people. So please do check it out, and don't be afraid, you can write it too. It just takes a little more effort, maybe a few more hours after you do your project, okay? But do write it as far as possible. And as I mentioned, we've shared some recommended data sets, and we've shared some example projects. So you can go through these projects, and you can keep revising this video as well to just get a sense of how you should analyze your data. And you can either use this notebook as a starting point. We've created this template for you where you can put in the project title, write some introduction, and then there are sections for each step. And remember to commit your work at each step so that you do not lose your work. Or you can also start from a blank notebook. That is perfectly all right. It's all a question of what you feel most comfortable with. And do remember to just remove this cell before your submission so that the instructions are not included in your final submission. Okay, so with that, we've just revised the course project as well, and you have time till the 3rd of October. That should be sufficient time. So please do put in the work. If you've come this far, you should definitely do a course project while you have all of these things in your head, and it will really reinforce all the ideas that we've learned. Now, I just want to do a quick recap of the course for a couple of minutes. And a lot of you started out without even Python programming experience. So we started out with an introduction to programming with Python. We just looked at the first steps with Python and with Jupyter notebooks, using it like a calculator. We explored data types and variables. We saw branching with conditional statements and loops. And then in the second lecture, we looked at writing reusable code with functions, working with the OS and the file system. And then you solved the first assignment where we solved some word problems using variables and arithmetic operations. We manipulated data types using methods and operators, and we used branching and iterations to translate ideas into code. And we also learned how to explore the documentation, how to get help from the community. So after learning Python, we looked at Numpy. So we saw how to go from Python lists to Numpy arrays. We saw how to work with multi-dimensional arrays, and we saw what were the different array operations, matrix operations that you can do. We learned about slicing, we learned about broadcasting, and Numpy by itself is a very powerful library. And we also saw how to work with CSV data files. Then we did an assignment on Numpy array operations where you explored the Numpy documentation and demonstrated the usage of 5 array functions. And you created a Jupyter notebook with explanations about 5 functions on how to use them and how not to use them. And we shared hundreds of notebooks with the community and probably learned a lot from each other. Then we learned how to analyze tabular data with Pandas, which was reading and writing CSV data with Pandas. We learned how to query and filter and sort data frames. And Pandas data frames are really powerful. And even today, we've seen a lot of different functions which we probably did not explore earlier. Then we also looked at grouping and aggregation for summarizing the data. We looked at merging and joining data from multiple sources. And then we did an assignment on Pandas where we applied all of these things that we learned. Finally, we had one lecture on visualization with Matplotlib and Seaborn, where we learned how to do basic visualizations with Matplotlib and advanced visualization with Seaborn. So things like line charts, scatter plots, bar charts, heat maps, and histograms. And then we also saw how to customize and style charts, how to make them beautiful. And we also saw how to plot images and how to plot multiple charts in a grid. So all of these things are, all of these things then we tied together into our today's lecture on exploratory data analysis, where we found a real world data set, the Stack Overflow developer survey with 65,000 responses. We loaded the data, cleaned it, pre-processed it, did exploratory analysis and visualization. Then we asked and answered questions, and we made a bunch of inferences. And now you're working on the course project, where you will repeat this process on a real world data set of your choice. So that was a quick recap of the course. Now what should you do next? Try out the notebooks yourself. You can revise any of the previous lectures. You can watch the videos. You can run the notebooks. It's a one click away at any point. Definitely try out the Stack Overflow survey results and some of the exercises there. And if you have any questions, you can always ask questions on the forum. I've been saying this from the start, people who are active on the forum are the most likely to complete. So if till now you've not checked out the forum, just go to zerotopandas.com and there is a link to open up the forum. So here you can see here, there's a course community discussion forum. Any question you have, we have topics for each lecture. So any question that you have, just go to that topic and first search through that topic. It's likely that your question has already been answered. And if not, you can always post a new post on that topic. Just reply to that topic and somebody will answer it. Like, we have an amazing course community, and we've been seeing huge contributions from people spending hours just answering questions from other people. So I just want to give a big thank you to them. So please do participate into the forum. Now, if you complete all the assignments and the course project, then, and once we evaluate all of that and you get a pass grade in all of them, then you will be issued a certificate of accomplishment. This will be a verified link hosted on jovian.ml. So it will be a page on jovian.ml, a part of your profile where it can be displayed. And this will be available for download as a PDF as well. So if you want to download it, print it out, you can do that too. And you will be able to add it on LinkedIn, onto your LinkedIn profile, so that anybody who visits your profile will see that you have completed a certification on data analysis with Python. And you will also be able to share it online on Twitter, Facebook, or wherever. So we've all put in a lot of effort. So we can definitely celebrate it once we earn the certificate of accomplishment. Do share it and even encourage your friends to take the course in future sessions. This is what the certificate looks like, but this will be embedded into a web page from where you will be able to download it and share this page as well. The thing you should not do is immediately do not jump to another course. Work on a project. Make your project as large and as interesting as possible, because it's not enough to say that you've done a course, and it's not enough to say that you have a certification. It's not enough to just say that you've done a small project. You should have a significant data analysis project under your belt, and it should be something that you have documented and presented well, and it should be something that you have put on your public profiles, right? So do something that you feel proud of, and then put it up on your public profile. Improve your professional profile, and write blog posts, write tutorials, and write guides. You can do this on Medium, you can do this on GitHub pages. There are a lot of platforms where you can write blogs. You can use Jovian to share your Jupyter notebooks, and I'll talk about that a little bit as well. But do write any guides that can help people who came before you. So look back at yourself and try to write maybe a small tutorial for that person to encourage them to demystify data science for them, or maybe just to tell them that Pandas is not as scary as it might seem, or maybe just point them to this course and say that you can learn about it here. So there are a lot of resources available online for you that you now know. And so you can now curate them and share them with your community, right? So if you're a student, share them with your classmates. If you're a professional, share them with your colleagues, share them within your company. The more you share your knowledge, the better you get at it as well. Okay. And then improve your professional profile. So showcase your certificate, showcase your project on your LinkedIn profile, on your GitHub profile, on your resume. So do that. And then once you feel like you've really done a lot of work on this topic, that is the point at which you should then take more data science and machine learning courses, right? So do not fall into the trap of just doing a bunch of courses without any real output out of them. The best way to learn is by doing good projects. Now you can use Jovian.ml to build your professional data science profile. And we are working on some very interesting improvements to the profile, a lot of which we've already added. So if you go back to just open jovian.ml and log in. So if you just go to my profile if you're logged in. So you can see here that on your profile you will be able to add more information. So on your profile you will see an edit button where you can add your current designation, you can add your current university or your company, and you can also link your GitHub profile. And here you can see a collection of all the notebooks that you have created so far. So any Jupyter notebook that you create anytime, any interesting analysis that you do, just upload it to Jovian. So just run jovian.commit inside it and it will get added to your profile. You can also upload notebooks directly. If you have a Jupyter notebook somewhere on, let's say you have somewhere on GitHub, or you have somewhere on your computer, you can upload that too, or you can import it from a URL. So you can do that. You can also create collections. So you can create collections where you see interesting notebooks joined together into a single collection. For instance, I have this collection on deep learning with PyTorch. I have this collection on data analysis with Python, Pandas, where I'm going to add a few more notebooks. So that's an interesting way to organize your notebooks. And you also get access to the forum as part of the profile. So try to answer questions on the forum, because that is then going to also reflect on your professional profile. The more questions you've answered, the more knowledgeable you are. So that's what it is to use Jovian, and all these projects that are hosted on Jovian, by default you have this really nice, beautiful, optimized view of the Jupyter notebook. You can these are mobile friendly views. So if you even open these on mobile, you will still be able to, they will load up really fast. We spend a lot of time just tuning the performance of these pages. If you're sharing a link to a Jupyter notebook, a lot of people are probably going to open it on mobile. And on mobile, this might not render well on different platforms. So please do use Jovian. It's a great way to share this. And it's also a great way to just show all the work that you've done, because the version history of a notebook shows how much work you've put in. So if you have a notebook with some 20 or 30 or 50 versions, and then you share that with somebody, then they can go through it and they can see that you've really put in a lot of effort into this. So a lot of this about your professional profile, a lot of it is about just showing what you've done, making it visible for people to discover and learn more about. Okay. And you can follow us on Twitter. So we are JovianML at Twitter. We keep tweeting interesting notebooks. We keep tweeting interesting resources for data science. In fact, if you tag us, if you share your notebook online and tag us, then we will definitely try and retweet interesting notebooks. We try and retweet 4 or 5 interesting notebooks every week at the very least. So we hope you find Jovian useful. And just on behalf of the entire course team, I just want to say a big thank you to you for being so active on the forum, for doing all the assignments and working on the project, going through all the lectures, and just being awesome overall. We were really excited to run this course, and this is really not the end. We are hoping that we will continue to have a long association with you. We have a lot of interesting things planned for you. So I will see you in the forums. This is the end of our lectures, but we will be able to interact with you via the forums. You can follow FreeCodeCamp, follow jovian.ml on Twitter, or follow me. So with that, we come to the end of data analysis with Python. Thanks a lot for joining, and all the best for those of you who are still working on the assignments on the course project. And I hope to see you soon in a future course. Thank you and goodbye.